Bismillah ar-Rahman ar-Rahim. Hello my dear students, how are you? I hope you are fine and enjoy good time and good health. Today inshallah we will resume talking about mathematics of finance with simple interest, chapter number 3, equations of value. We will start with equations. We use the amount formula S equal B times 1 plus RT, and the present value formula B equal S over 1 plus RT. The first exercise: a debitor signed a note for $2,000 due in 1 year with interest at 12%. 3 months after the debt is contracted, the holder of the note sells it to a third party who determines its value at 16% simple interest. How much does the seller of the note receive? In this example, we can solve this problem like the way of the chapter 2, or we can use the method of equations of value to solve it. At the beginning, we must draw the timeline. This is the timeline. The date of note is now. The maturity date after 1 year. The discount date after 3 months from now, or before 9 months from the end. Look at this exercise. A debitor signed a note for $2,000 due in 1 year with interest at 12%. This means that this note is a commercial note with interest bearing note. We need to get the amount of $2,000 after 1 year. Then we must discount the value of this amount. At the beginning, we must use R equals 16% to get the amount. Then we use the amount to get the value of X. Value of the note after 1 year is equal B times 1 plus RT. The maturity value of this note 2,000 times 1 plus 12% times 1 equal 2,240. Note that according to this timeline, now we have an old obligation 2,240. We need to replace this with X. If you know that the focal date lies before the maturity dates, then the present value of all the obligations equal to the present value of X. The present value of X equal to X because the time of X equals 0, or the distance between X and the focal date equal to 0. So to get X, we need to get the present value of 2,240. Value of all the obligations, or value of all the debts, equal to value of new obligations or debts. So X equal 2,240 over 1 plus 16% times 9 over 12, which is equal $2,000. Another example. A borrower signs a note for $4,500 due in 6 months with interest at 12%. 2 months after the note is signed, the holder of the note sells it to a buyer who charges 18% simple interest for discounting. How much does the seller receive? We can revision the 3 cases of equations of value. The first case, if the focal date lies after the maturity dates of old and new obligations, then the amount of old and new obligations are equal, or the amount of old obligations equal to the amount of new obligations. The second case, if the focal date lies before the maturity dates of old and new obligations, then the value of old obligation, the present value of old obligations, equal to the present value of new obligations. Present of old equal to the present of new. The third case, if the focal date lies in between, then the amount plus the present value of the old equal to the amount plus the present value of the new. Or we can say it, the amount of sum of old obligations plus the present value of the others equal to the amount of sum of new obligations plus the present value of the others. Look at the exercise number 2. A borrower signs a note for $4,500 due in 6 months. We must draw this note. Look at the timeline. Now we have a note which is signed with 4,500 due in 6 months. So we must get the amount after 6 months. Now it's called date of note. After 6 months, maturity date of note. He discount it after 2 months. So after 2 months is called the discount date. At the beginning we must use the formula of S equal B times 1 plus RT to get the maturity value of the note. Then we can use the formula of equations of value of old obligations equal to value of new obligations to get X. Note that the time for the amount of $4,500 equal to 6 months. After 6 months, the amount will be equal 4,770. Then we need to replace 4,770 with a cash payment deserved after 2 months. We need to replace these old obligations with a new obligations equal to X. In this case, the focal date lies before X and before 4,770. So the present value of old obligations must be equal the present value of X. The present value of X equal to X. The present value of 4,770 equal to 4,500. Look at this slide. At the first, we get the value of the note after 6 months. At the second, we get the value of X. Value of the note, we use the formula S equal B times 1 plus RT. We get X with 4,770. The total time here equals 6 months. At the second, whereas the focal date lies before the maturity dates of old and new obligations, then the value of old debts equal to the value of new debts, then the value of X equal to X, and the value of 4,770 equal to 4,500. So X will be equal $4,500. Note that the time for 4,770 equal 4 months because it's the distance between the maturity date and the focal date. This type 1, 2, 3, 4. Exercise number 3. A debitor owes $1,500 due in 1 year. He agrees to pay $500 in 3 months. If one is worth 13%, what payment must he make 15 months hence to retire the receipt of the debt? Put the focal date 15 months hence. Again, a debitor owes $1,500 due in 1 year. He agrees to pay $500 in 3 months. If money is worth 13%, what payment must he make 15 months hence? In this example, we have one old obligation. We need to replace this old obligation with 2 payments. The first deserve after 3 months and the other deserve after 15 months. We have 1,500 after 1 year. After 3 months he pay 500. We need to get the balance after 15 months. The focal date here after 15 months. Note that in this example he say put the focal date 15 months hence. After withdrawing the timeline, the focal date lies after the maturity dates of old and new. In this case, the value of old, the value of $1,500 equal to the value of new obligation. We have 2 new obligations, 500 plus X. So the value of 500 equal to 500 times 1 plus RT, and the value of X will be equal to X. Now we need to calculate the time for the old and the new obligation. The time for $1,500, not 1 year, it's 3 months, because it's the distance from the last month of the first year to at the end of 15 months. This distance from the maturity date of 1,500 to the focal date, which is equal 3 months. Also, we need to get the time for $500. The distance from the maturity date of 500 to the focal date, from 3 to 15 equal 1 year. You can calculate or you can count. This distance will be equal 1 year or 12 months. At last, the time of x, the distance here equal to 0, so the time of x will be equal 0. Value of old obligations equal to value of new obligations. X plus 500 times 1 plus 13 times 1 year equal to 1500 times 1 plus 13% times 3 over 12. In this example, x plus 565 will be equal 1548, and to get x, 1548 minus 565, so x will be equal $983.75. Exercise number 4. A woman owes $6,000. She and her creditor agree that she can pay $2,000 now and the balance in 6 months. Find the payment in 6 months if the settlement is based on an interest rate of 16% and the focal date is 6 months hence. At the beginning, we must draw the timeline or time diagram. The old obligations equal $6,000. She pay $2,000 now, immediately, and we need to get the balance after 6 months. We have 2 ways to solve this problem. The first way, by using the formula of equations of value. The value of old obligations equal to the value of new obligations. Look at this time diagram. We have one old obligation. We will replace the old obligation with 2 new obligations. One deserve now and the other deserve after 6 months. The focal date here after 6 months. From the timeline, the focal date lies after all the obligations of old and new. So the amount of old obligations must be equal to the amount of new obligations. The amount of $6,000 equal to the amount of 2,000 plus x. We get x as its value, as its payment, because the amount of x equal to the present value of x equal x. The time for $6,000 equal 6 months. The time for $2,000 equal 6 months. The time for x equal 0. We can use a rate of 16% to get the solution of x. Value of old obligations must be equal to value of new obligations. We have one old obligation, $6,000. We can use the formula of the amount, S equal B times 1 plus RT. We're substituting for B with $6,000 and for R with 16% and T with 6 months. So the value of old obligations equal 6,000 times 1 plus 16% times 6 over 12. This is the left hand side. The right hand side value of new obligations. We have two new obligations, 2,000 and X. 2,000 times 1 plus 16% times 6 over 12 plus X. The value of old obligations will be equal 6,480, and the value of new obligations will be equal 2,160 plus X. And to get X, X will be equal 6,480 minus 2,160. X equal $4,320. Other solution. At the beginning, we must get the receipt. Note that in this timeline, we have old obligations now with $6,000. At the same time, she paid $2,000. So the balance now equal $4,000. We need to get the $4,000 after 6 months. So we can use the amount formula S equal B times 1 plus RT. So X equal 4,000 times 1 plus 16% times 6 over 12. In this example, X will be equal 4,320. Look at the result of this solution and the other solution. X equal 4,320, the same result. This is the last example for now. Thank you for watching. For any question, leave your comment at the bottom of the video and I'll try to answer it next time.